of Basic Electronics, myself Hamid Satwara, and today we are going to start with new chapter which is AC analysis of BJT and its amplifier. So here this is the first topic, AC analysis of BJT and load line. We have discussed earlier about DC load line, but here in this topic we are going to discuss about AC load line. So that is a big difference between DC load line and AC load line. So now first we have discussed earlier about BJT, that is bipolar junction transistor. So here we are going to discuss about bipolar junction transistor, that means NPN and PNP transistor. So here let us start with amplification first. These are the few definitions which will be helpful for our further topics. So first is amplification. So it is the process of adding strength or magnifying the input signal without changing its shape. That is known as amplification. Now we are going to use here amplifier. For amplifier there should be characteristics. Here we can see these are the few characteristics which are most important for amplification process. So we have seen here number one, which is voltage gain. So what is gain? Gain, that means it is the ratio of output upon input. It is known as gain. Now voltage gain, that means output voltage upon input voltage, known as voltage gain. So number two, it is input resistance Ri. Number three, output resistance Ro, and number four, power gain AP. Here we can see power gain. It is also power gain, that means output power upon input power, which is known as power gain. Now among these four, these two, input resistance and output resistance, we are going to measure at the input side and output side accordingly. So here we can see if we set these characteristics for amplification, then and then you will get pure amplification signal. So next one is coupling capacitor. What is coupling capacitor? Coupling capacitor, that means we are going to use two different types of capacitor in circuit diagram. Which one is going to connect with the input side and other one is going to connect with the output side. So here we can see it couples or transmits AC signal to the resistor. It blocks DC and allows AC signal. Coupling capacitor works well at all frequencies only if Xc is small as compared to the resistance at the lowest frequency of the AC source. That means here we can see it blocks DC and it allows AC signal. How? So then we have to discuss about Xc and XL. Now this is the capacitor, so we are going to discuss about Xc. What is Xc? That means it is capacitive reactance. Now capacitive reactance equation is Xc is equal to 1 upon omega c is equal to 1 upon, we can say, 2 pi Fc. Now here 1 upon 2 pi Fc, F, that means frequency. So in DC there is no frequency, or we can say 0 Hertz. So that's why we can say here in DC it would be block and AC it would be flow, because there is a particular frequency in alternating current in AC signal. That's why it blocks DC and allows AC signal. Now bypass capacitor, it is one of the capacitor which bypass the signal, which bypass the current to the ground. Here we can see the capacitor connected in parallel with the emitter resistor. Re is called as emitter bypass capacitor. So due to bypass capacitor we will get good gain. That's why these definitions are important for the further theory. Amplification its characteristics, bypass capacitor and coupling capacitor. Now remember this thing, these parameters, we can also say about parameters is most important for theories, because we are going to discuss about various types of model in this chapter. So for that we have to set, or we have to find few equations of voltage gain, input resistance, output resistance and power gain. So among these four, these three are most important for the theories. So remember this for the next topic. Now here let us discuss about in depth for bypass capacitor. What is bypass capacitor? Here in this figure we can see one capacitor is placed parallel to the resistor. That means it is bypass. Okay, so current doesn't flow through this resistor and flow from the capacitor. Then here we can see in figure A, bypass capacitor in amplifier, where CE, that means ammeter capacitor, RE, that means ammeter resistance. Now here in B figure we can see CEXL short circuited at the medium and high frequency. How it becomes short circuited? Because we already discussed earlier that X is equal to 1 upon 2 pi MC. When you going to increase the frequency, then XE is inversely proportional to the frequency. So we can say here CEX as short circuited at medium and high frequency. Now what about low frequency? Here we can see at low frequency HCE is comparable to RE. Here we have to set few equations, then and then here current can flow. Now basically we can say XAE does not equal to 0 for low frequency. So this is the fundamental of bypass capacitor. Basically current flow from the capacitor side at the medium and low frequency, at the medium and high frequency. So basically resistor is bypassed. So that's why it is known as bypass capacitor. Now next one is AC load line. We have discussed earlier that DC load line. Now it is similar to the AC load line. DC load line CC, that means collector capacitance, acts as a open circuit, but for AC it acts as a short circuit. We discussed earlier that capacitor, if we are using capacitor in the circuit diagram, for DC it will be open circuited and for AC it will be short circuited. AC load line represent the AC operating conditions for the circuit. Here we can see this parallel combination RC parallel RL is always less than RC. Therefore the slope of AC load line is higher than that of the DC load line. Here we can see comparison of DC load line and AC load line. This straight line which is connected to the current axis and voltage axis is known as DC load line, but here we can see which is connected to the voltage and directly goes up, that is AC load line, and between there we make the point which is known as Q point, quiescent point. So there is no difference between the Q point and its stability and its different types of regions we have discussed earlier. We discussed three various types of region in BJT: saturation region, active region and cutoff region. So for this we are going to use it in amplification. That's why its Q point is at the center in the graph. So this is the difference between the AC load line and DC load line. We can see from this figure. So here parallel combination of RC parallel RL is always less than RC. Why it becomes less than RC? Because RC which is connected at the collector side and RL which is connected across the transistor side. So between RC and RL there is a one capacitor. If we are using here AC, that capacitor becomes short circuited and RC and RL becomes parallel with each other. Here we can see in this circuit diagram, this is RL, here this is the capacitor, and above we can see here this is the RC, and due to this capacitor becomes short circuited, RC and RL becomes parallel, and due to this it is always less than RC, and we can see from this graph. So what is the difference between the AC and DC load line? So here we can see three main topics and parameters. Number one, when to be used. DC load line is always used for biasing the transistor, whereas AC load line is used for as an amplifier. Number two, slope. We have discussed for DC load line there is an equation minus 1 upon RC, whereas here the equation becomes minus 1 upon RC parallel RL due to capacitor becomes short circuited between the RC and RL. And number 3, load line less than that of the AC load line. Actually DC load line is less than that of the AC load line, and in AC load line it is higher than that of the DC load line. So this is the difference between the AC load line and DC load line. So remember this thing, DC load line is used for biasing the transistor, whereas AC load line is used for the amplification method. So this is the biggest difference between the DC and AC load line in analysis topic. So that's all for today's lecture. If you have any query related to this topic, you can mail me on this email address. Till then, keep reading, keep learning. See you soon in next coming lecture. Thank you.